how are you all? I hope everyone is doing wonderful. So let's get started with solving the questions on JEE Mains previous year question solving sessions, and this is lecture number 12 on the topic of definite integrals. So definite integrals or definite integration is a very important chapter which plays a pivotal role in your JEE Mains. So this chapter must be prepared very nicely. So let's get started with solving the previous year questions on the topic of definite integrals, and this is my take on top 10 important questions from JEE Mains previous year of definite integrals. So let's get started with the very first question. So again, so students who have been watching this particular series, then they must know that you can find this playlist of this particular series in the description box of today's video. And as well, when you are starting to solve the question, pause the video at this particular moment with on the start of each question and solve the question on your own. And after getting the answer, tally the answer with my solution. Okay, so that's how we actually proceed. So if you have covered the syllabus of your preparation for mathematics portion, then I would recommend you to do the same. So let's get started with the very first question, and the question says that we are given with the integral. So let me write the integral. So it is given with from the limit 0 to pi by 3, and it is said the integrand is cos to the power 4 x dx, and it is given that this particular integral value is equal to a times of pi plus b times of root 3. Now we have to look for the unknowns, that is a and b, in this problem. So it is said that a and b are basically rational numbers. Okay, so a and b are basically rational numbers. Now how are we going to proceed with this particular problem? So before proceeding with the problem, you must be knowing the trigonometric formulas of half angle. So I can write, so what I can do, I can write cos x as, what I can do, I can write cos x as 1 plus cos of 2 times of x divided by 2, because if we look at the half angle formula, we all know the half angle formulas for the cos is basically cos square x minus sin square x is basically equal to cos of 2x. Okay, so from here, if you manipulate and replace the sin square x as 1 minus cos square x, you will find this particular result. Okay, so okay, I forgot a square over here. So this is cos square x is basically equal to 1 plus cos 2x divided by 2. Now what I have to look for in the problem is basically cos to the power 4. So let us square both the sides. So this is the value of the cos to the power 4. Now I can write the integral as follows. Therefore I can write the integral as from the limit 0 to pi by 3. Okay, the integral will basically be equal to 1 plus cos of 2x divided by 2 whole square dx. Now let us proceed further and write this. This is integral from 0 to pi by 3, and first of all let me take 1 by 2 whole square common, and that will basically become 1 by 4, and then expand this by the square, that is 1 plus cos square of 2x, okay, plus 2 times of cos of 2x, and that is basically the integrand. Dx is the integrating factor, the integrating factor, or you may say the differential with respect to the unknown variable. So this is basically equal to 1 by 4 times of, now what I can again simplify as that, so over here we again have cos square 2x. Okay, now I can simplify cos square 2x as, now I can simplify this cos square 2x as 1 plus cos of 4x divided by 2. Okay, so I can again apply the half angle formula, and I can write this cos square 2x as this particular value. So in doing so, what I did, I basically simplified the relations for which I know the integration formulas. So this basically become 1 plus, and this is basically again going to be 1 by 2 plus 1 by 2 cos of 2x. Yeah, so from here what we can observe is it is going to be 1 by 2 times of cos of 2x, cos of 4x. Let me change this. So this is going to be cos of 4x plus 1 by 2. Okay, I have written 1 by 2 already. So then let us erase it and write, and that's going to be 2 times of cos of 2x. Okay, so this is the integrand, and once you can, therefore this is basically the format which is basically easy for integration. Okay, and you know the formulas for all. So let us move forward and let us solve the integration. This is going to be 0 to pi by 3. Now I'm multiplying 1 by 4 with each of the terms, that is 1 by 4 plus 1 by 2, okay, plus 1 by 2 cos of 2x plus 1 by 4 cos square 2x. Okay, that was basically the integrand. Okay, that was the integrand. So from there, okay, so this is basically again simplified. Okay, this is going to be, so let us simplify, and this is coming out to be 3 by 8 times, okay, 3 by 8 times plus half times of cos of 2x plus 1 by 8 times of cos of 4x. So I clubbed all the terms and I got this particular result. Okay, now you can simplify, and this is going to be 3 by 8x plus 1 by 4 sine of 2x plus, and this is going to be 1 by 32 sine of 4x. Okay, and with the limit 0 to pi by 3. Now if you can put the limit and solve, you will basically definitely get to the result, and the result is something as follows. So you can put this pi by 3 over in the first time, so the result is going to be coming out as something as what I calculated is pi by 8 plus 1 by 4 times of root 3 by 2. So you can definitely solve this on your own, minus 1 by 32 times root 3 by 2. So that's what the result I was getting. And if you can simplify, this further simplified as pi by 8 plus root 3, sorry, 8 root 3 minus root 3 by 64. That is basically 7 root 3. So that is what the answer I was getting. And if you can club with or the given result, so the given result was something of the fashion a pi plus b times of root 3. So you can see, and if you compare the corresponding terms, you will get the value of a as, you will get the value of a as 1 by 8, and you will get the value of b as, you will get the value of b as 7 times 7 divided by 64. Okay, so we'll get the value of b as 7 divided by 64, and both of them are rational numbers. So from here you got the values of a and b. So the question, it is asked in the problem to calculate for this particular expression, that is, sorry, so that is basically 9 times of a plus 8 times of b, and that is basically equal to, so a value is basically 9 by 1 by 8. Okay, 9 by 1 by 8 plus 7 into sorry, this is basically 8 times of b, and that we can simplify 8 into 7 by 64, so that will be 7 by 8, 7 by 8. So 9 plus 7, it is going to be 16 by 8, and that is the, with this the result is going to be 2, and that is option number a, this particular problem. So the right answer to this particular problem is going to be option a. I hope this is a fairly simple problem. Only the thing that you need to be careful about is basically know the half angle formulas. So definite integrals basically require some of the trigonometric formulas. So it is basically advisable to revise the chapter of trigonometric identities in order to get back to all these formulas. These are very basic formulas which you must remember in order to solve any problems of your plus 2 levels. Okay. So with this, let us move to the next problem. So next problem, as you know, is on our screen. So again, I would say the same thing, pause the video at this particular moment and try to solve this particular problem on your own, and then tally the answer or the solution with mine. So if you can see this particular problem, so this is a fairly important type of problem, and it involves the use of properties. So again, definite integrals basically has three types of questions. One question is basically going to be on the properties, and there are other questions which basically involves the definite integrals as expressing as limit of sum or corresponding the or doing the reverse thing, or as well as there are questions which involves the solving limits using of definite integrals, which where you have to apply the Newton-Leibniz rule. Okay, so what we can see over here, let us solve this. The integral is given as from the limit 0 to pi by 4 x into dx. So, and in divided by sine to the power 4, sine 2x whole to the power 4 plus cos 2x whole to the power 4. So that is basically the integrand. Now, what idea is basically you have to look for this particular problem is that whenever you see that from over here inside the bracket is basically 2x, so why not change it into some other variable where it basically involves only one variable terms without any other constant variable. So let us assume. And also another striking factor, whenever you see a question on definite integral and you can see a complex expression along with the x in the numerator, you will always get the idea that this is basically given to simplify the x from out of this expression by taking the King's property or the property where basically you use the property, and let me write the property over here. So the property of a definite integral is basically whenever you are integrating with the limit a to b of any integrand f of x dx. This can also be written as within the limit a to b, this can be written as f of a plus b minus x into dx. So if you can change this x variable to this particular, that the this doesn't change the value of the integration. So this actually simplifies many of the results, and this is very important property, also known as the King's property. So let me write it over here, King's property of definite integrals. Okay, so that's how you basically remember. So this is the King's property of definite integral. Di stands for definite integrals. Okay, so that's a very important property you must remember, and if you have studied the chapter, you know how important this particular property is. So with this, let us move and solve over here. So what I wanted to do is basically let 2x is basically equal to t, and once I let 2x is equal to t, then let us differentiate both the sides. So I will get 2 times of dx is basically equal to dt, and from here the integral therefore becomes 0 to pi by 2. Okay, and with for the variable term is basically t. So from here, if you replace x with t by 2 and dx with dt by 2, okay, dx with dt by 2, and whole divided by sine to the power 4t plus cos to the power 4t. Okay, so that is going to be the integrand, and from here I can simplify and solve it as, so this is going to become equal to integration within the limit 0 to pi by 2. Okay, and this is going to become equal to t dt. Okay, t dt whole divided by, and 1 by 2 into 1 by 2 is going to be 1 by 4, and this is going to be equal to sine to the power 4t plus cos to the power 4t. Okay, now I will apply this particular result. So if I apply this particular result, this particular integrand can also be written as within the limit 0 to pi by 2, 0 to pi by 2, and you know a very important thing, that is basically the rotation of integrations. Okay, so sorry, not the integration, it's a trigonometric equations. Okay, so trigonometric result actually follow some cyclic results. Okay, so if you replace sine x with pi or even multiples of pi plus the particular angle, then it does not change the trigonometric ratio. But in case if you change it with the x or t with some and with some odd multiple of, or odd multiple by means to say odd multiple of pi by 2, then in that particular result the trigonometric identity change to the reverse, that is cos change with sine and sine change with cos. You know this particular result. So what I will do over here is that I can write this as pi by 2 minus of t. In place of t, I am writing this as, by using this particular result. Okay, 0 plus pi by 2 minus x, that is minus t over here, and dt whole divided by, and in place of t I will replace it with pi by 2 minus t. So sine of pi by 2 minus t is going to be equal to cos of t, and that is again that this result is going to be remaining the same because there is even power to this. So the negative powers or the negative terms is going to be taken care of, and this is again going to be same as cos to the power 4t plus sine to the power 4t. Now I wrote this by my own to so that there is a change. Okay, there is actually a change, but the overall term is unchanged. Okay, the overall terms is unchanged. Now this is also equal to I, and this particular integral value is also equal to I. Now this is first equation, and this is the second equation. So from 1 and 2, so from equation 1 and 2, what I can imply is that if I add both the equations, what I'm going to get, 1 by 4 is going to be common, and for the integral within the limit 0 to pi by 2, it is going to be t dt divided by the term that is sine to the power 4t plus cos to the power 4t plus pi by 2 minus t dt, okay, divided by the same thing, that is sine to the power 4t and cos to the power 4t. Now what you can observe, if you add this particular terms, if you add both the terms, you will see that the t will get cancelled out, and that basically simplifies the entire problem. And with this you will get over here is basically going to be 2 times of I, or integration value, that is going to be equal to pi by 8. So pi by 2 and coming out is a constant, it will definitely come out of the integration, and is going to be pi by 8 within the limits 0 to integration within the limit 0 to pi by 2, and the result is going to be dt divided by sine to the power 4t plus cos to the power 4t. Okay, now from here, in order to solve this particular problem, what I will do, I will take cos to the power 4t common, and in doing so what I will get is a very important thing that you must remember. So this will be again equal to pi by 8, 0 to pi by 2. So this is going to be, if I take cos common over here, so I'm going to be at sec to the power 4 t dt Okay, and cos to the power 4t I am taking it common, so sec to the power 4t is going to be 1 by cos is basically sec, so that's going to be the result, and this is going to be again coming out as tan to the power 4t plus 1. Now why did I do so? Now you know a very important thing, that is differentiation of tan x is going to be equal to sec square x. So that's the important implication. So if I assume, now again if I let tan x as some variable p, I will get sec square x dx, or let me write this tan t as p, then sec square t dt is going to be equal to dp. So this simplifies the result as pi by 8 times, sorry, the 2 times of integration value is equal to pi by 8 times of within the limit. Now the limits will change. This is going to be limits change as 0 to infinity, and this is going to be equal to, so this is going to be equal to, so again another thing is very important is again 1 sec square t will remain over here. Now I will apply that particular result, that is sec square x is equal to tan square x plus 1. Now this trigonometric identity I'm applying over here, so I can write this as 1 plus p square, okay, p square dp. Now whole divided by, this will be going to be 3 to the power 4 plus 1, okay. Now this again simplifies the results, okay. Now again what I can do, now this particular type of integration falls under one category where you have to take common by p square. So if you take common of p square, so this result is going to be pi by 8 times of within the limit 0 to infinity, and this is going to be 1 plus, so I'm taking p square common, so this is going to be 1 plus 1 divided by p square dp. Now since I took p square common, so this is going to become equal to p square plus 1, and if I have this p square plus, sorry, p square divided by 1 plus 1 by p square, now I have to club this in form of a perfect square. So what I do, I add plus 2 and minus 2 simultaneously, and in doing so I'll get the result is simplified as pi by 8 times of 0 to pi by 2, okay, and this is going to be 1 plus p square, okay, dp. Now I know what p minus 1 by p, if I differentiate that, then I will get this particular term, that is 1 plus 1 by p square. So if you have solved this, then I can express this particular as 2 plus 2 plus p minus 1 by p whole square. Also important thing is to remember is that I can represent this particular denominator part also as p plus 1 by p minus p plus 1 by p whole square minus 2, but I didn't do so because I need to get to the this particular term, that is 1 plus p square 1 plus 1 by p square dp as the above term. Again, now if I imply this particular as some quantity as q, then I will get this is the perfect differential of this particular dq. So I can replace this and write this as pi by 8 times of 0 to infinity, sorry, not 0 to infinity, I did one mistake over here. It is basically, I forgot to change the limit over here. This is basically p limit is basically from 0 to infinity. Okay, p limit is going to from 0 to infinity. That means then that means q will basically range from, so if you look at q, now this will value will again range from this limit will change, and this will change from minus infinity to plus infinity. So minus infinity to plus infinity, and the result is going to be looking something like pq divided by 2 minus q square. Now you can simplify this particular result, and you can easily do this as, okay, so you can simplify this particular result as you can take 2 or root 2 common over here, and this particular will basically, sorry, there is a plus over here, okay, sorry, plus, okay, 2 plus q square, and this is basically looking like the formula for tan inverse x, okay. So from here if I continue, so from here I will continue over here, so let me erase this particular part, so let us erase, okay. Okay, so I will write that for same thing above over here. So what I did over here is that I assume tan t as equal to p, and similarly I assume p minus 1 by p as q, and definitely can do the differential part as well. So from here you'll get the result something like pi by 8. So now I will take root 2 as common, okay, root 2 common out of there. So the result I will be getting is minus infinity to plus infinity, that is dq divided by, so from here if I take 2 or root 2 as common, okay, what actually I need to get the result of something like 1 plus x square. The denominator part should be something like 1 plus x square. So what I do, I take 2 common, and that result leaves me with 1 by root 2 whole square, okay. So let me write it properly. So it is better to write like this fashion, that is 8 by 2, and then I write this as q by root 2 whole square. Now this is going to be equal to, pi by 8, and then this is going to be tan inverse of q by root 2. Okay, tan inverse of q by root 2, and then again divided by 1 by root 2, and 2 and 1 by root 2 will cancel out as 8 into root 2. So that is going to be the value of the integral, that is 2 times of I. This is the value, okay, from the limit minus infinity to plus infinity. And if you put the limits and if you solve for I, okay, and if you put the limits and solve for I, so you will get the value of I over here. You will get the value of I from here as basically root 2, sorry. So from here you will get the value of I as root 2 pi square by 32. So that is the value of the integral. So that is the value of the integral. So you can understand this particular problem is little bit complicated. Okay, so if you have someone who is for the first time solving this particular problem, this problem might seems to be complicated at first. But I will say that when you practice this type of problems a lot of time, these habits, these kinds of limits or integrations becomes very simple to you, all of you, because you know how to take this particular thing as common. This is basically a type of integral. If you have studied the chapter of definite integration, then you must have covered there are various types of solving the integrations. Okay, so this is one of the type of integral where you have to solve. Okay, so with this, the answer to this particular problem is going to be option number C, that is root 2 pi square by 32. That is root 2 pi square by 32. So that is option number C. So I hope if you have tried this particular problem on your own, you might have got the answer as root 2 pi square by 32. So this particular solution is clear. So with this, let us move to the next problem. And the next problem is again a very interesting problem. Okay, so let us read this particular problem, what it has tries to say. That it says that they are basically two functions f and g, and both of the function has basically domain from 0 to infinity to codomain as a real number. Okay, this maps from 0 to infinity to real number, and there are two functions which are defined by, one of the function f of x is defined as minus x2 plus x mod of t minus t square multiplied with e to the power minus e to the power t square dt. So this is basically f of x, and similarly g of x is basically defined as 0 to x square 0 to x square e to the power 1 by 2 into e to the power minus t dt. Now this is a very interesting problem. Why? Because these types of problems are actually asked from previous year. If you find the old problems of JEE Advanced, you can find these types of problems. So these problems actually are coming somewhat or the other in your JEE Mains examination. So you can definitely look out for the previous year problems of JEE Advanced as well. Okay, so let us try to solve this particular problem. So let us try to understand what this particular problem has to say. Now this particular integral has a variable limits. So whenever I will be saying an important thing, that whenever you will find in variable limits, then you understand that instead of solving that particular integral, try to solve or get out the derivative of that particular function of which the integral has a variable limit. So from here, if I try to find out f dash of x, that is by using the Newton-Leibniz rule, what I will find, okay, by using the Newton-Leibniz rule, and before applying the Newton-Leibniz rule, let us understand that this particular mod of t minus t square into e to the power minus t square is a basically an even function. So replacing this minus x to x, the integral, with 2 times of 0 to x is not a very big problem. So that means I can replace it with 2 times of integration with 0 to x mod of x minus mod of t minus t square into e to the power minus t square dt is basically the same result. And therefore if I differentiate it, this result is going to be 2 times of, and in place of t I will put x, that is mod of x minus x square into e to the power minus x square into differentiation of x, that is going to be 1. Okay, so that is basically, this is the result of the f dash of x. So let us write this as equation number 1. And similarly, I have gx. So what I can do, I can differentiate gx, and I can write this as g dash x as equal to, so g dash x basically will be equal to t, this is going to be x. This is going to be x into e to the power minus x square into differentiation of x square, that is going to be 2x. And this is basically, let me write this as equation number 2. Okay, so now what I can do is that now if I look at this particular problem, it is asking me to calculate the value of 9 times of f of log of this particular root quantity plus g times of this particular quantity. Now before doing so, let us understand, and what I can get from here is a very important and interesting result, is that if I club these two particular terms, that is f dash of x plus g dash of x, if I club this or sum up, what I will get, the 2 times of x square e to the power minus x square will actually get cancel out. So the result we are left out with is going to be looking at the fashion. Now see, I can replace this because x basically for the functions, both of the functions, the codomain, sorry, the domain is basically defined as 0 to infinity, so that is positive result. So I can replace this mod of x with x, simply as x. So this is going to be 2 times of x into e to the power minus x square, and this particular term and this particular term actually get cancelled out when you multiply with 2, and this particular term actually get cancelled out. So what I can get is that f dash of x plus g dash of x is going to be this particular value. Now there is a very interesting result, is that if you integrate the left hand side, if you integrate the left hand side, that is f dash of x plus g dash of x with respect to dx, okay, and that is also equal to integration of the right hand side, that is 2 times of x into e to the power minus x square dx. Okay, now let me integrate within the limit 0 to alpha. Okay, 0 to alpha. Now if you do this particular integration, you can find that this is going to be the right hand side. So let us simplify. The right hand side is going to be coming out as f of x plus g of x. Okay, within some particular integrating limits. Okay, within some particular integrating limit, and if I replace x square with some value as t, then I will get 2 times of x. Dx is basically dt, and that is going to be 0 to root alpha, 0 to root alpha, 0 to root alpha e to the power minus t, e to the power, sorry, e to the power minus t. Okay, so there is some problem with the slides, I understand over this particular part. Okay, so this is going to be 0 to root alpha e to the power minus t dt. Okay, and with this you can simplify this particular integral as e to the power minus t minus 1 multiplied divided by minus 1, so that is minus 1, and the limit is 0 to minus alpha. So what I can put, I can put alpha as, so I can put alpha as log of 9 base e. So that is going to be satisfying the result, that is, so in place of alpha, so this is also, I'm integrating with 0 to alpha, so the result is also over here is going to be f of alpha and g of alpha, because I integrated within the limits 0 to alpha, 0 to alpha. Okay, and alpha is basically this particular value, that is log of 9 base e, and for doing so I will get the value of f of root under. Okay, so it is better to put, let me check. Yeah, so it is better to put like root alpha. Okay, it is better to put root alpha. So from there I can simplify this result. Okay, so it is better to put root alpha, that is log of 9 plus g times of root under log of 9 base x, so that is going to be equal to, so this is going to be coming up this particular result. So if I put over here, and this is going to simplify the result as minus e to the power, minus e to the power, and log of 9. Okay, log of 9 whole to the power. Okay, so log of 9 whole to the power minus 1, this particular value, plus of 1. Okay, sorry, the plus of 1 is going to be in the exponential term, exponential over here. Okay, so plus of 1, and that is going to be equal to, so I can replace this, okay, this minus 1, and the result is going to be coming out as, so from here then I will get 9 times of, or instead of doing that, okay, instead of doing that, so since I assume the x value, okay, since I assume x as log of or root under log of 9, so what I can do, that x square will definitely satisfy the result, that is better to write like over here, that is x and that particular value. So instead of writing alpha and alpha, I will replace with that. Okay, so that I will write it as x and over x over here, same. Okay, and from here I will get the 9 times of f of x, that is x is going to be this particular value root under this value. Okay, x is going to be this particular value, so f of x plus g of x is equal to, is going to be equal to 9 times of 1 minus 1 by 9. Okay, this I can simplify by using the base changing formula, that is a log b with base a is going to be equal to b log of b to the power log of um, log a base a. So that is going to be simplifying, and that is going to be coming out 9 to the power minus 1, and that is 1 minus 1 by 9, and this is going to simplify the result as 8. So from here you'll get the result as 8. Okay, so this result is going to be 8. So I hope you can understand this particular problem. So this is a very interesting problem. Okay, so once you get this particular result, okay, once you get this particular result, it is easy, and you can differentiate it or integrate it and get to the final problem. Okay, and you can integrate this to get to the final problem. Okay, so quite interesting problem. Okay, just you need to think that how you can pretend and try to solve this problem. So whenever you have a function which is basically given in terms of unknown integral limits, then definitely try to understand that particular problem can be solved by using taking the differentiation of that. And once you add, the difficult terms get cancelled out, and that particular integrand becomes simplified or easy to solve. So that's the basically entire idea. I hope you have understood this particular problem. Quite a interesting problem. Okay. So with this, let us move to the next problem. And the next problem is on our screen. So the problem says that, so we are given with a function. So let me change the color. Okay, so we are given the function, and that basically with a domain real part 2 and maps to the real part, that is codomain also real. We have function which is defined as f of x is defined as x divided by 1 plus x to the power 4 whole to the power 1 by 4. So that is defined as f of x, and g of x is basically a composite function which is defined as f of f of f of. So there are 4 times of f of x. Okay, yeah, one more bracket. Okay, so that's basically the function. Now let us understand how to solve composite functions. So since the domain and the codomain are basically simplified in terms of real number, so we don't have to be worried about the looking at the domain or the codomain of this particular composite function, which you have studied in the chapter of functions. I hope you have studied that particular in the chapter of functions. Then these particular things are going to be simplified. So instead of doing so, let us find f of a f of f. Okay, let us find, sorry, so let us find f of x. Okay, f of x. Okay, or you can call this as f of x, x. Okay, so with this will be basically f of x whole divided by 1 plus f of x whole to the power 4 whole to the power 1 by 4, and you can simplify this result as x divided by 1 plus x to the power 4 whole to the power 1 by 4 divided by 1 plus x to the power 4 1 by 1 plus x to the power 4, this whole to the power 1 by 4, and you can simplify this particular result. This result is going to be coming out as, and you can simplify this result is going to be coming out as x divided by 1 plus 2x to the power 4 whole to the power 1 by 4. So that's going to be the result of f of x. Okay, now similarly you can do another thing, that is, now f instead of f of x, okay, f of x, so instead of x you put again the same thing, that is f of x, and that's how you get to the gx result. Okay, so in place of x you put the value again, that is 1 plus x divided by 1 plus 2x to the power 4 whole to the power 1 by 4. So that simplifies the result, and this is going to be coming out as x whole divided by 1 plus 4 to the power 4x to the power 4 whole to the power 1 by 4. So you can simplify this particular result on your own instead of x, and in place of this particular x you put f of x. Sorry. So this particular simplifies the result as something follows. Now we are given out to find the value of the integration, that is 18 times of integration within the limits 0 to, so let us check the limit. So that is basically root under 2 root 5. So that is basically root under 2 root 5, and I have to find for the limit integrand, that is x square into g of x dx. So if I solve this, it's going to be 18 times of, now the limit is root under 2 root 5, and this is going to be x square into x whole divided by 1 plus 4 times of x to the power 4 whole to the power 1 by 4. Now this is going to be coming out, this result is going to be x cube. Now what I can do from here, I can let x to the power 4 as t, then in doing so I'll get 4x to the power 3 dx is basically equal to dt, and that simplifies the result as 18 by 4 into dt over there, and the limit is going to be 0, and for this particular value the limit is going to be, or instead what I can do, it is better to assume this particular value. Okay, it is better to assume 1 plus 4x to the power 4 as t. Then you will get the result as, 16 times of, okay, then you will get the result as 16 times of x cube is basically equal to um or let this assume as 1 plus 4x to the power 4 as equal to t to the power 4. So this is going to be, 4 t cube dt. It is better. Why? Because 1 by 4 term is also there. Okay, so to simplify that result I can do that also. Okay, so from there what I will get is this, basically this is t cube dt, whole divided by this 4, and this particular value is basically t to the power 4, and whole to the power 1 by 4 is going to be simplified as t. Okay, so this is 16 over here, and this 4 and 16 get cancelled out with 4 times, so I divide by 4, and the result is going to be, 9 by 2 t square dt integration within the limit 0 to, so within the limit 0, sorry, not 0, that is going to be 1. Okay, within the limit 1 to, and in place of x I put root under 2 root 5, so this will be simplified as 1 plus 4 times of, so that is going to be equal to 2 root 5 into 2 root 5. So you can simplify and you can find this t to the power 4. So t to the power 4 is going to be 81. So that value of t is going to be 3. Okay. So from there, within the limit 1 to 3 t square dt, and that is going to be coming out as 9 by 2 into 1 by 3 t cube, 1 by 3 t cube, and within the limit 1 to 3, and this is going to be simplified as 3 by 2 into 27 minus of 1, and that is going to be 13 into 3, and that is, the result is going to be coming out as 39. So with this you can simplify this particular result, and the result of this particular problem is going to be option number C. So I hope if you have solved this particular problem on your own, you must have got the answer as option number C. And this important thing was that how to simplify this result of composite function. So once you can simplify the composite function, the rest question is basically a cakewalk. Okay, and this is just a simple pretty exercise that you basically perform every time when you solve the questions of definite integrals. Okay, so with this let us move to the next problem. Okay, so the next problem is very interesting problem, and if you look at this particular problem, it says that there is a function, and y is basically the function, that is f of x is basically thrice differentiable function. It is basically thrice differentiable. Okay, so you can differentiate it 3 times, thrice differentiable. Okay, thrice differentiable in the domain that is -5 to 5, both are open. So let a tangent, okay, so it is saying that, sorry, it is saying that let the tangent to the curve, okay, it is saying that the tangent to the curve y is equal to f of x at 1 comma f of 1 and 3 comma f of 3 makes an angle pi by 6 and pi by 4 respectively with the positive x-axis. Now if the value of this integrand, okay, if the value of this integrand is equal to alpha plus beta times root 3, where alpha and beta are integral values, then find the value of alpha plus beta. So quite an interesting problem. Let us understand what this particular problem has to say. Now this is the curve, okay, this is the curve. It is saying that the tangent at point 1 comma f of 1 and the tangent at 3 comma f of 3 actually makes an angle pi by 6 and pi by 4 respectively with the positive x-axis. That means it is basically talking about the slope. So if you look at this particular problem in this fashion, that if this is a particular curve and there is a tangent to this particular point at this particular point, and this is the angle which is made by the slope, or made by the tangent with the positive x-axis. So this is the x-axis and this is the y-axis, so let the angle be alpha, then tan of alpha is actually known as a slope, and that slope in terms of differential or calculus is basically defined as dy by dx. So to get to the slope of the tangent, what I perform is basically dy by dx. Okay, dy by dx at different points. So let us firstly find dy by dx. So that is going to be f dash of x. So for the point at x is equal to 1, f dash of 1 is going to be equal to how much? That is basically tan of pi by 6. So tan of pi by 6 is going to be 1 by root 3, and similarly f dash of, in place of x we put 3, then f dash of 3 is basically tan of pi by 4, that is going to be 1. So we have two boundary value or the boundary conditions, that is f dash of 1 is equally 1 by root 3 and f dash of 3 is going to be equal to 1. Now from here what I look at this particular problem as 27 integration within limits, sorry, within the limit 1 to 3, 1 to 3, f dash t plus 1, okay, f dash t whole square plus 1 into multiplied with f double dash t dt is equal to, given the problem as alpha plus beta times the root 3. Now, firstly, let us try to understand what this is going to be. So, if I assume that f of t as some parameter or condition as z, so let me write over here. So, let us assume f of t as a parameter z. So, this is a let, and then f double dash t is going to be f double dash t, sorry, I am better writing as f double dash t dt is going to be dz. So, from there the integration will simplify 27 times of within the limit 0 to 1, that is going to be f dash of 1, and this is going to be f dash of 3, and we know the respective value of f dash of 1 and f dash of 3, and this simplifies as z square plus 1 into dz. Okay, and if you can further simplify, this is going to be equal to z cube by 3 plus z win for the limit, okay, within the limit 1 by root 3 to 1, and multiply with 27 as the constant. So if you simplify this particular problem, so you can simplify this particular problem, and the simplification will be basically 27 times of 27 times of, so 4 by 3. Okay, so I have solved this. This is going to be 4 by 3 minus 10 by 9 into root 3. Okay, you can solve this on your own and you'll find this particular result. Okay, uh, even if I not, okay, I did a, okay, yeah, it is perfect. And from here, if you multiply with 27, is going to be getting the values as, so this is going to be 36 minus, and again, if you take this multiply with root 3 again, so 10 root 3 into 3, and this 3 into 20, this is going to be cancelling out, and this is going to be equal to 36 minus 10 root 3, and the value basically given in the problem is basically alpha plus beta root 3. Okay, alpha plus beta root 3, where alpha and beta are the integral values. So from here, you'll get the value of alpha as 36 and beta as minus of 10, and beta is minus of 10. Now you have to solve for alpha plus beta. That means the value of alpha plus beta is going to be equal to 26. So you have actually got the result, that is the value of alpha plus beta is actually option number A, that is 26. So I hope you have solved this particular problem on your own. Quite an interesting problem, okay, but a simple problem as well. Okay, let's move to the next problem. And with this, let us solve the next problem. And the next problem is very important problem. If you it's this type of problems are actually clubbed under the category of definite integrals as a limit of sum. Okay, so let me write it as definite integrals as limit of sum. Okay, so if you want to understand what this particular question, I can give you a simple and a brief understanding is that whenever you have a whenever you have a given curve, okay, and that curve actually encloses some area, and this particular curve is basically y is equal to f of x, okay, and this particular curve is integrated between the limit a to b. So the definite integral of this particular curve is actually implies that this is basically the area under this particular graph. So in order to solve this particular area, what I did is that I took some small strips of rectangles, okay, small strip of rectangles, and I and replace the integration of limits a to b of f of x as sigma or summation for the for n is equal to 1 to of many infinite strips. So it is better to write as n is equal to 0 to, okay, n is equal to 0 to, or let me consider for n strips, okay, for n strips, okay, and what I did and for this particular n strips, so what I did, this particular, you can see the width of this particular rectangle. Now this particular width will be coming out as b minus a divided by n, okay, b minus a divided by n, sorry, that is the number of rectangular strips that you are dividing it. So if you are dividing into n strips, okay, if you are dividing this particular interval into n strips, the length of the each interval is going to be coming out as b minus a divided by n, that is going to be, so I can write this, so this small interval or dx, I can write this as b minus a divided by n, and this is a value. So now when I have this particular as a small strip, okay, so if I have this small strip, I can simply be replaced by these values or interval values with a simple average value, and for this particular curve, these values and these values are going to be same. So that's kind of approximation I'm dealing with for this particular definite integral. And now you can write this particular definite integral as a summation of this particular multiplication, that is So this particular value is going to be, so you can take for within this particular value, so whatever the value is coming out, so I can write this as f dash of x dash and into the dx, the small element. So this is the area, so this is the area of the rectangular strip, and if I sum up all the area of the rectangular strip, I actually get the area under the curve with some bit of errors. Okay, so that is going to be an important challenge, okay, whenever we have to find the error in terms of the numerical integration. Okay, so that is the some part which you're going to be studying in your college level. Okay, so let us not get worried about that. So the important thing that you need to understand, that whenever you have something like a limit, okay, and this is basically a limit, okay, so you have to get the limit when n tending to infinity. So for all the summation of the rectangle, when n is very small, that is a limit n tending to infinity, that is infinite strips, you are dividing the entire interval of the function within a to b in terms of in infinite rectangles, then you apply this result. And if you have the some result something like this, so now let us get back to the question, and the result says that there is a limit where n tending to infinity, the summation is given of the variable terms is k from 1 to n, n cube, n cube, n square plus k square into n square plus 3k square. Now very important result is we need to understand, whenever replacing the limit of an summation with the integral, you just need to do one important thing, is that the important thing that you need to perform is that you replace k by n as x, you replace k by n with x. Okay, again I'm speaking, you replace k by n with x, and you replace 1 by n, and you replace um, actually, yeah, and you replace 1 by n with dx. Okay, so from here, if you solve further, so this limit can also be simplified as limit n tending to infinity, the sigma. And what I do, I take n square over here. Okay, so firstly let us multiply with 1 by n. So if I multiply with 1 by n, then it is going to be n to the power 4, and then I divide by n square over here and n square by over here, then this particular result is going to be simplified. So this is going to be coming out as, 1 divided by 1 plus k square by n square into 3 times of a square by n square plus of 1. What I did is basically n to the power 4 over here, took out n square common over here and n square common over here, and n square into n square into the power 4, and this n to the power 4 actually get cancelled out with n to the power 4 over there. So now this particular result is simplified as limit n tending to infinity sigma k is equal to 1 to n, 1 divided by 1 plus k by n, and k by n whole square plus 1 into 1 plus 3 times of k square by n square. So that is the result of the limit of summation. Now I will replace the limit of summation in form of the integrals, and that is going to be when the limit 0 to 1, okay, that is going to be dx y 0 to 1. Okay, that is a question again, y 0 to 1. So if you see this is the value is basically n. So n has no constant terms associated with over here, so that's why 0 to 1. Now what is the basically the condition for understanding what is the value? So you have just have to divide by n. Okay, so whatever the value will present over here, divide by n and take the limit of that, n tending to infinity. So from here the value of the k is basically ranges from 1 to n. So if you divide 1 by n, so you divide 1 with n, there is 1 by n, and then take the limit, that is going to be 0. So the lower limit is going to be 0, and the upper limit n by n is going to be 1. Okay, so that is 0 to 1 and into, so I can take 3 common as 1 plus x square, and then I can write this as 1 by 3 into x square. Now this is the going to be the integration. Okay, now this is the integration that you need to perform. Now what I can simplify and write this as 0 to 1 by 3, and if you take 1 by 3 common and multiply with 3 by 2, I can write this integration as in terms of partial fraction. I'm trying to write this integration in form of partial fraction. So 1 by 3 plus x square, and what I do over here is that I write 1 plus x square minus x square plus 1 by 3. Okay, so that is going to be 2 by 3, and then I'm multiplying with 3 by 2. Okay, so that is simplifies the or cancel out the result. So this is the integration, and from here you'll get the integration as 1 by 2 within the limit 0 to 1, 1 by 2 within the limit 0 to 1, that is going to be dx divided by x square plus 1 by 3. Okay, and minus dx, so 1 by 2 integration with the limit 0 to 1 dx, and this is going to be 1 plus x square. So we know the formula for this particular integral. Okay, and this value is going to be coming out as 1 by 2. Now you can simplify these results as root 3 times of tan inverse of x, so root 3x. Okay, you can simplify. You can take this, multiply with 3 and then take 3 out of there, and you can do your simplification on your own, and that is going to be within limit 0 to 1 minus, okay, so this is going to be minus 1 by 2, and that is simplified going to be tan inverse of x. Okay, and with the limit 0 to 1, so you can simplify this on your own. So I have done the simplification, and the simplification something comes out as root 3 by 2 pi by 3 minus 1 by 2 into pi by 4. Okay, 1 by 2 into pi by 4. So you can simplify this result, and the result is going to be 13 pi divided by 8 into 4 root 3, 4 root 3 plus 3, 8 into 4 root 3 plus 3. That is the value of the integration. So that is the value of this particular integration, or the summation of the limit. Okay, limit of summation. So with this, the result of this particular problem is going to be 13 pi divided by 8 into 4 root 3 plus 3. That is option number C. So option number C is the right answer to this particular problem. So quite a simple problem, and if you have understood the particular problem, then it is very important, because these types of problems actually will get repeated in some point or the other fashion. Instead of having this expression, you might have different expression, but these types of problems will get repeated, because I have seen this particular problem getting repeated many times in a JEE Mains examination, any of the shift. Okay, so with this you can understand this is very important problem. Let us move to the next problem. So the next problem is another problem which basically involves limit and it is saying that there is a function which is on the domain minus pi by 2 to pi by 2 closed to and ranges from the codomain real number is a differentiable function. It is a differentiable function, and it is also said that f of 0 is going to be 1 by 2. Now it is said that the limit x tending to 0, find out the limit of this particular, that is x into integral 0 to x f of t dt whole divided by ex square minus 1 is equal to alpha. Now, in order to apply the Newton or Newton limits, that is important different thing. Okay. Now, in order to, whenever you have a limit which is basically the format 0 by 0 or infinity by infinity, we definitely think of applying the L L'Hopital rule. Okay, or many people call it as L Hospital rule. Okay, so let us apply the L L'Hopital rule or LH rule. Okay, so whenever we have the limit, let us firstly find out this is basically a 0 by 0. Okay, 0 by 0 form. So therefore, we can apply the LH rule, and if we apply the LH rule over here, so this particular limit can be easily solved as limit x tending to 0. Now we have to differentiate the numerator and the denominator separately. So if the differentiation of the numerator is going to be so the differentiation of the, firstly I will take, this is a product of two terms. So firstly I will differentiate x and keeping the other terms constant dx, and then I will differentiate this particular term, that is going to be x into f of x into 1, that is the differentiation of x, and whole divided by, and this is going to be e to the power x square into 2x. Okay, e to the power x square into 2x. Okay, and okay, so that is the result. Now what I can see from here is that um, again, if you look at this particular, this is going to be again of the fashion 0 by 0 form. So therefore again I can apply the LH rule, and then I can simplify this as, okay, then again I can apply the LH rule. Okay, so I guess I have done it correctly. So this x and x will get cancelled. I can cancel out this x and x. So again, if I apply the LH rule, okay, or you can do one more important thing, is that you know the value of this particular limit, that is whenever you have a limit, or this is a standard limit. Okay, when x tending to 0, e to the power x square minus 1 divided by x square, this value is going to be equal to 1. Okay, these are standard limits, so you can do that manipulation. Okay, you can do this manipulation on your own, divided by x square and multiply the x square to simplify. This result is going to be 10 into 1. Okay, and then you can simplify on your own. So if I do that particular simplification, that basically simplifies the result. Okay, and if you do that particular manipulation, that LH rule will be give me a different result, and that result is going to be of the fashion, that is limit x tending to 0, and the numerator part is going to be 0 to x f of t dt whole divided by x, and then again if I apply the LH rule, the limit is going to be, because it is again going to be 0 by 0 form, so then this particular value is going to be f of x divided by 1. and that basically simplifies the result as f of 0, and we know the value of f of 0 as 1 by 2. So with this, the value of the limit is going to be 1 by 2. Okay, so that means alpha is basically 1 by 2. So 8 times of alpha square is basically 8 into 1 by 4, and that is going to be 2. So quite a simple result. Okay, quite a simple problem. Very, very simple problem. So the result is going to be option number B, that is 2. Okay, so just you need to understand like how to apply the LH rule for, and which case the LH rule actually applicable. Okay, that is 0 by 0 form, and then you apply the LH rule, and for taking out the differentiation of an definite integral, you basically apply the Newton-Leibniz formula. Okay, of one variable. Okay, and then you basically get to the result, that is the limit value is 1 by 2, and the value of 8 alpha square is going to be equal to 2. That is option number B. I hope you have understood the particular problem. Okay, so with this, let us move to the next problem. Okay, so I have got a next problem, and that is another interesting problem. Okay, that is again a problem on limit. Now you can understand the limits problems are actually very important, and you can find there are many problems on limit which involves definite integrals. Okay, so the limit is over here, it is given as, so this particular problem is very simple problem. You just apply the LH rule, because if we look at this particular integral or the terms over here, you will find this is of the fashion of 0 by 0 form. So that is x minus pi by 2 whole square, and the integration is x cube, and pi by 2 whole cube, and the integrand is cos t to the power 1 by 3 dt. Okay, so now if I apply the LH rule, I'll get the limit value as x tending to pi by 2. The integral, that upper term will be equal to 0 minus of, so in place of t to the power 1 by 3, I put x cube. In place of t, I put x cube. So that is going to be x cos x into, and then differentiation of x cube, that is 3x square, whole divided by, and then this is going to be equal to 2 times of x minus pi by 2. 2 times of x minus pi by 2. Now from here, you can simplify the result as, now I will use the result, that is sin x by x. For x tending to 0, the result is going to be 1. So that is x tending to pi by 2, and if I replace this with if I replace minus of cos x with sine of x minus pi by 2, I'll get the result. Okay, and then multiplying with 3x square. Okay, 3x square, and over here if I take 2 minus x by 2. Okay, 2 minus x by 2, and yeah, there are no issues. Okay, if I am missing some quantity, please tell. Okay, so please let me look out for any missing quantity. Okay, I don't think there is any missing quantity. Okay, yeah, so from here you'll get again the result, that is sine of x by x, but x tending to, but the inner part. Okay, the inner part, the sine of t by t, and if t tending to 0, this particular limit is going to be equal to 1. So the inner part is going again something which tend to 0, and divided by something which is again 0. So sine that particular something divided by something is basically tending to 1, and with this the result is going to be, I believe I have missed a by 4 term over here. Okay, I think, so yeah, there is 1 by 4 over here. Okay, so this particular term, and then if I club this, so the result is going to be 3 by, so that is pi by 2. Okay, oh sorry, very sorry, not 5 4, sorry, that is I'm thinking in advance. Okay, actually I'm putting x as pi by 2, x, then x square will be pi square by 4. So that's what I was thinking. Okay, so this will simplify the result as 3 into pi square by 4 into 1 by 2, and that is going to be the result, that is 3 pi square by 8. So the result is going to be 3 pi square by 8, and that is option number B. Again, fairly similar problem. Okay, which basically again use the LH rule, and for differentiating the integral or the definite integral with variable limits, you just need to apply the Newton-Leibniz formula. So pretty simple problem, and with this let us move to the next problem. Okay, so the next problem is on our screen, and this is a very important problem. Okay, so if you try to understand, so there is a printing mistake, that is 2023. Okay, so just check it over here. Okay, that is going to be 2023. Okay, because this question came in 2023. All right, so the integral is saying that it is the integral in the limit minus pi by 2 to pi by 2 x square cos of x divided by 1 plus pi to the power x. Now this type of option actually came up in your JEE Advanced previous year problems. Okay, if you look at very old problems of JEE Advanced, you can find this particular problem. Then 1 plus sine square x whole divided by 1 plus e to the power sine square, uh sine x to the power 2023. So this is going to be how, and this is going to be x to the power 2023. Okay, and dx. Okay, so that is basically the integrand. Now, how to solve this particular problem? Now, what I can do, I'll firstly think of applying the King's property. Why do I do so? Now, many times in a question, when you don't know how to approach with the definite integrals, it is always advisable to apply the King's property and understand or try to get a hint like on what pattern this particular question can be approached. So if I apply the King's property, then I can write this as, so in place of x, I just need to put by minus x. Why? Because a plus b is basically equal to 0. So a plus b minus x. So that's what I'm applying. And then x square will remain the same. And cos of x again will remain the same because cos is an even function. And this is going to be 1 plus pi to the power minus x. Okay. Plus, and this is going to be again sine square x because sine is an odd function but square makes it an even function, and divided by 1 plus e to the power minus sine x to the power 2023, because x to the power 2023 is an odd value and sine of odd is again an odd. So this is the integral. Okay, and for solving this, now what I do, these are the two equations. So if I add the two in integral, the value is going to 2i, and that is going to be equal to, now within the limit minus pi by 2 to pi by 2, if I add the both the terms, what I will get is that, so on adding, you can definitely solve this and see that on adding you will get the result as something very simple, that is x square into cos x is going to be same, and if you add 1 divided by 1 plus pi to the power x plus 1 divided by 1 plus pi to the power minus x, that is again going to be, now this result can be simplified, this particular result can be simplified as pi to the power x by 1 plus pi to the power x, and if you cancel out the 1 plus pi to the power 1 by 1 plus pi to the power x plus 1 by 1 plus pi to the power minus x, is basically comes out the result as 1. So that is this integrand result, this is again on adding, it is going to be giving out x square plus x square into cos x plus, and this particular result is going to be 1 plus sine square x. The similar hold for this particular also. Okay, that this particular result of 1 by 1 plus e to the power minus sine x to the power 2003 can also be written as e to the power sine x to the power 2023 divided by 1 plus that particular result. Okay, so with this you will get the simplified expression as 1 plus sine square x plus cos x, x square into cos x. And if you do this particular integral, okay, and if you do this particular integral, you can find the result and of integration I as basically, so you can apply the by parts formula for here is x square into cos x. Okay, x square into cos x, and for this particular result you can simplify the solution, and again for sine square x you can again replace it by 1 minus cos 2x divided by 2. So that's the trigonometric identities, and if you solve this, you'll find the result is going to be pi square by 4. So pi square by 4 plus 3 pi by 4. So I'm leaving the result up to you to solve. Okay, I'm just giving the answers. Okay, which I've solved it on my own. Okay, you can simplify. This is very simple. This is very simple. Okay, given minus 2, and with this you'll get to the value that is basically of the format pi by 4 into pi plus alpha or a minus 2. So from here the value of a is going to be equal to 3. You can simplify, you can take pi by 4 common, that is pi plus 3, the a value is going to be 3. So with this the right answer to this particular problem is option number B. Okay, fairly simple problem, just apply the King's property and even just ready to go with the result. Okay, so these type of questions are actually very well known, okay, in the definite integral, and this particular property of the applying the King's property, so I actually applied over here, I applied the King's property, which I've already mentioned in the first problem, sorry, in the second problem. Okay, so just apply the King's property and you are good to go. That's it. This, let us move to the last problem for this today's particular discussion, and that is another important problem. Again, you can simplify this particular problem with the help of the King's property. So let us understand like how we can apply. Okay, so from here, if we see the integral is basically when the limit 0 to pi dx whole divided by 1 minus 2 times of a into cos x plus a square. Now this is an integral. Now what I do, now also given out that a value lies between 0 and 1. Okay, so what I do, if I apply the King's property, so let us apply the King's property, that is integration a to b f of x dx is basically equal to integration with the limit a to b f of a plus b minus x, a plus b minus x into dx, and by applying this particular property, I will get the result as 0 to pi, and I just need to replace x with pi minus x. Okay, so that is going to be 1 plus, because cos of pi minus x is going to be minus of cos x. So 1 plus 2a times of cos x plus a square. Now what this is also equal to the integration, that is I. Okay, now this is equation number 2 and this is equation number 1. So if I adding 1 and 2, okay, so let me write this equation number 1, this is equation number 1. So from here, if I add 1 and 2, I'll get the result as 2 times of integration within the limit 0 to, sorry, let me not change the limit of the integration firstly. Okay, so that is going to be 0 to pi, 0 to pi, and I can solve this as, um, you can solve this. Okay, you can take the 1 divided by, and this numerator terms, and club them both the numerator terms. You can easily solve this and get to the perfect square as 1 plus a square to whole square minus 4 times of a cos square x, 4 times of a square cos square x. Okay, so you can simplify this result, and similarly the numerator will become equal to 2 times of 1 plus a square into dx. Okay, and but since I did so, I just changed the limit of the integration as 0 to pi by 2 and 2 over here. Now this I can do only for the case of even function, or if the function basically yields the result, that is f of x is basically equal to f of a minus x for the integral limit within 0 to pi, or 0 to a, sorry, 0 to a. So for that I can apply this particular property, and then from here the from 2 and 2 got cancelled, and this is basically equal to, is going to be equal to 0 to pi by 2, and the result is going to simplify it as 1 plus a square, 1 plus a square. And if I take cos square from the denominator part as common, then the upper term will be having sec square x dx. Okay, and divided by the result is going to be 1 plus, okay, so I think I have missed a, okay, okay, no, so that is going to be equal to 1 plus a square whole square into sec square x, and in sec square x I can write this as tan square x plus of 1 minus minus 4 times of a square dx. Okay, so this I can also simplify as 0 to pi by 2, and instead of pi by 0 to pi by 2, let me change the limit of the integration, or and simplify this as, let us assume that tan x is equal to t, then I can write sec square x dx is equal to dt. So I wrote 2 times of dx, 2 times dx. Okay, so I already wrote dx. So with this, the result is going to be simplified as, 2 times of 1 plus a square dt whole divided by 1 plus a square whole square t square plus 1 minus 4 times of a square. And again you can simplify, and for the limit 0 to infinity, and this is the value of the integral. So for this particular integral, I can again simplify 1 plus a square. If I take common 1 plus a square, I'll get the result as 2 divided by 1 minus a square. Okay, 2 divided by 1 minus a square. Okay, you can solve this. Okay, you can see this. If you take 1 plus a square common, so this will be divided by 1 plus a square, and then again if you simplify, it is going to be equal to 2 divided by 1 minus a square, and this 2 is from here. Okay, and the result is going to simplify as tan inverse of t, and within limit 0 to infinity, and that is going to be pi by 2 minus 0, pi by 2 minus 0, and which basically simplifies the problem as, and this simplifies the problem as, so that is going to be equal to pi divided by, so this 2 and 2 get cancelled, and pi divided by 1 minus a square. Okay, so that is the value of the integral. I have done this particular problem in little bit of a quick or fast approach, but if you are not able to understand, just I applied the King's property and then I simplified over here. So I skipped some of the steps over here, okay, that you need to understand. I skipped some steps over here that you need to understand, okay. Just you can do it on a rough copy. You can take this particular denominator and you club them, okay. You'll find that this particular result actually holds true. You multiply the 3 terms with the another 3 times, so you get 6 terms, and that corresponding 6 terms can be simplified in by this particular fashion, and then you will get the numerator. So with this, and then I apply the change of limit for half of the change of the limit, and then with this the limit of the integration will get simplified to this particular result, and which can also be simplified by applying this trigonometric substitutions, that is tan x is equal to t, and then sec squared x dx is equal to dt. Then I solve this particular integration by substitution, and then I get to the result of the integration as pi divided by 1 minus a square, and that actually simplifies the problem. And with this, the right answer to this particular problem is going to be option number C. That is option number C. So I hope you have understood this particular problem. Okay, fairly simple problem, but only requires calculations. Okay, so if you are good to go with the calculation, then everything is sorted. Okay, so I hope you have enjoyed and solving all the problems along with me, and you have understood the chapter of definite integration. Okay, so there are important problems from definite integration chapter. So if you can prepare these important types of problems nicely, along with I cannot guarantee you that these are the all types of various problems that is in the chapter of definite integrals. But since I need to take up the top 10 important problems, I took these particular problems. So my responsibility is just to give you an idea what are the different types of important problems. Now your task is going to be practicing out different problems on definite integration. Okay, now once I will be starting with the topics of definite integration, I will be giving you lot of problems, as well as if you want to get more problems on definite integration and you want to practice more and more, you can comment me in the comment section by commenting as definite integration problems, okay, and I will be replying you back with the PDF of the problem statements. Okay, so with this I come to the end, and